So subtracting integers is pretty much the exact same thing as adding them, but just there's one more thing to think about. So we have this problem here, -6 minus 3. Looks kind of challenging, just like weight subtraction. Ooh. Number line is 0, 1, 2, 3, 4, 5, 6. I'll provide a bunch of extras here. 2, 3, 4, 5, 6. Here's -6 right here. So our starting point is. Now if we're going -3, that means we're going to the left 3 spaces. 1, 2, 3. Plops us there at -9. So, lots of ways to think about this. Number line is actually the clearest example in this one, but there's other ways to figure this out. I could always rewrite -6 minus 3 as -6 plus -3. In reality, there's no such thing as subtraction. It's just adding a negative number. This adding of a negative number is the same as subtracting. Mind blown, I know. Subtraction is a massive lie. So with that said, you could draw a little t-chart, plus minus. This could also be in your noodle. You have 6 in the negative side, 3 also in the negative side, for a grand total of 9 negatives. Same answer. Okay. I would highly recommend doing that. The other way to think about it is, okay, this is -6. This is -3. They're being shoved together to make a total of -9. Works the same way. Any logic here is fine as long as you're consistent about it. So, for example, let's do it not negative. Let's do 8 minus 10. Okay. Now 10 minus 8 is 2, but this is not what that says. It says 8 minus 10. So, what do we have here? We have here positive 8. There's an assumed positive here. May not be written, but it's assumed. So 8 is over there. 10 is negative. Because they're in different boxes, we do subtraction. 10 minus 8 equals 2. But here, negative is the winner. There's more of it. So our answer should be -2. Okay? That's option 1 for logic. Option 2 for logic looks like this. We rewrite it as a addition problem using a negative integer. Same grouping. 8 in the positive, 10 in the negative. There are more negatives than positives, so we just do 10 minus 8 and get 2. And because negative is the winner, there's more negatives, becomes -2. Okay. Alternative logic. I'll try to draw this. 0, 1, 2, 3, 4, 5, 6, 7, 8. Draw a couple on the negative side because we're going to need it. We're going to be moving to the left -10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 2 on the negative side. Same logic. Slightly more challenging example, the double negative situation. You have 5 minus -3. Doozy. Okay, we could rewrite this as 5 plus -3. I just turned this into that. Wait, but negative. Well, you're gonna learn a multiplication that negative times negative equals positive. So this is really like saying 5 plus 3, which should give us 8. Well, shortcut. When you see this double negative, it's the same as being just positive addition. It's actually the easiest one, just doesn't look like it. Now, if you have -3 minus -4. Well, so many negatives. But you're an expert now. This shouldn't be that challenging. This double negative becomes I know you said it, positive. So now you have -3 plus 4. In your head, or on a t-chart, 3 is in the negative, 4 is in the positive. There are more positives than negatives, so you'll just do in your head 4 minus 3 and get 1, and because positive wins, positive 1 is your answer. Okay? That's probably actually the most challenging one. There's just negatives everywhere, but there's really no stop once you understand how it works. Thanks.